Hi everyone, today we are here with a new problem, and the problem is shortest path in a binary matrix. So it is a medium type of problem, and yes, it is between the easy and medium. And first we see what is the problem, and then we see how we can solve it, right? So basically in this problem we have a given n cross n binary matrix. Why binary matrix? Because it consists of two values, which is 0 and 1. So what we have to do, we have to return the length of the shortest clear path in the matrix. If there is no clear path, then we have to return -1. Here what is clear path? So clear path in a binary matrix is from top left, which is 0 0 index, to the bottom right, which means the last n cross -1 and n -1 index. So all the visited cells of the path are 0, and we can move in the a directions. what what we mean by this, let's understand this with this example. So basically let me give the indexing 0 1 2 and 0 1 2. So basically in the starting we are at this point, and we have to go at this point, right? You can consider that 0 is a clear path and 1 is obstacle. It means where 0 is present we can go to that cell, but where 1 is present we can't move to that cell. Okay, the another thing is, let's suppose we are at this position or we are at this position, we can move to the a direction, which means this direction, this direction, this direction, this direction, this direction, this. So basically we can move in this direction. Okay, I hope you get it. Now what we have to do, now to go from this position to this position, one path is we can go there, there, then there, then there. In this, how many cells we have to go through? 1 2 3 4 5, right? And we have to find the shortest path, right? We have to find the shortest clear path. So this is not a shortest clear path, because we can move from there, then directly there. So how many cells we have to iterate? We have to iterate the 4 cells, which is 1 2 3 and 4. Now basically how we can solve this problem? So you can try a different approach to solve this. You can pause this video and try it once, and if you are not able to solve it, let's see how we can solve these problems. So basically in these type of problems where we have a given cell and we have to move through from some index to some index with some constants like this, in that case we have to always think about some recursive, okay, or some iterative approach. Okay, where actually what we have to do, basically let's suppose in this problem we have given that we can move in a direction. So let's suppose we are at the zeroth index. So what do you mean by a direction? It means we can go at 1 0, right? We can go at -1 0, we can go at 0 1, then we can go at 0 1, right? Not 0 1, we can go like -1 0. If we go to this direction, which is 1 and 1, if we go to this direction, so it is -1 0. If you go to this direction, so it is like if we move to this direction, right? So what it is -1 and -1. And if we move to this direction, then it is -1. And so let's suppose this is the zeroth row, it is -1, and we are at this, so basically it is also -1, and here in that case it is 0 1, it is -1 1. So basically these are the directions, right? If we are at 0 0 direction, we can move to this a direction. Now this is good. After that, the third thing that we have to take care is a boundary condition. Okay, what it is? A boundary condition. Boundary condition means, for this, if we are at 0 0th index, if we move to this side, so there is no cell, so this is a boundary condition where we don't have to check. If we move to upside, this is a boundary condition because there is no cell. If we go to this, there is no cell, but there is cell, there is a cell, there is a cell. So another thing is, in these type of problems we have to understand the boundary condition, and that's it. Now what we do, basically, let's suppose we are at the zeroth index, and for that we basically take a stack and push this zeroth index, and the cost is initially 1, right? Because we are at this cell, so this is 1 cost. Now for this, how many cells we can iterate? We can iterate only this one cell, right? Because one is not a clear path, this one is not a clear path. This is a boundary condition, this is a boundary condition, and this is also boundary conditions, right? So we can only consider this one path. So let me write indexing 1 2. So for this, we only have 0 1 index, and what is the cost now? 0 1 and 2. So the cost is 2 if we move from there to there. Now we are at the 0th one index. Now from there, where we can move to this, and we can move to this. Other than that, this is not a good case, this is not a good case, and other one is boundary. So what we do, we can simply, and also let's suppose we visit this one, and if we are at this, so if we move back, so we already iterated, so the cell which we iterate before, we have to convert their value to 1, such that we can understood, okay, this one is already processed, so we don't process it again, right? Otherwise, this cell is again processed, and this cell is again processed, this cell, and we get the TLE error. Now, so we have two things, this one which is 0 2, and this one which is 1 2. So if we remove this, so what is the null cell, which is 0 2 and cost is 3, and for this we have, let me clear it little bit, which is 1 and 2, 1 2 and cost is 3. Now you can see we remove this one cell, right? And this is 0 2. For this, we have to first make this one so that we don't iterate it again. For this, we can take it again, the only thing we can take it again. So we all again put this out, and make it 1, and write 1 2 and 4, right? Because here the cost is 3, now the cost is 4, right? Let me make some more space. Okay, now we remove 1 2, which is this cell, right? And we make it 1 after remove out from it, and then what we push this. So we have 1 2 4 already, we have to push 2 2, and what is the cost? This is 3, the cost is 4, right? Now we pop this from the stack, and when we pop, we can see that 2 2 is the index where we have to go. So this is the destination, and when we reach at the destination, we have to stop and return this 4, and this 4 is the length, right? And that is what we have to return. Now there is one question in your mind, is it obvious that every time we get the shortest path? Yes, it is. Why? Because when we go from there to there, and when we reach there, we have two things, this thing and this thing, right? And where we have to stop? We have to stop when we reach at this index, right? So let's suppose we reach at this index and we reach at this index. Now you can understand from there, this cell reaches fast than this cell, right? And if this cell reaches there, it will go through two more cells, right? Till there the cost is 3, and till there the cost is 3 if we come from there, right? So it reach fast than this, and when it moves from there to there, it increment by 1, which is 4, and we can simply return 4. I hope you understand this. Otherwise, we will see the code and understand from there. So let's see the code. We simply check one more thing. Let's suppose if our starting position, which is this 0 0, if it is 1, we are not able to start, or if this is 1, we are not able to reach. In that condition, we simply return -1 because we are not able to find a clear path. Other than that, we simply take a stack, and in that stack, what we do, so basically it works as a queue. How it works, let me show you. So we basically push 0 0 and the cost is 1. So 0 0 is the index, means the first cell we are at, right? And the cell where we are at, we make it 1 so that we are not process it again. Now we loop this queue, which is ij is the index and d is the cost. If we reach at the last index, we simply have to return the cost. Other than that, we have to go through all these 8 positions, and for this x and y, we need to check the boundary conditions, and we also have to check the new cell should not contain value 1. In that case, we first make this thing as 1 so that we not process it again, and again push it in the queue, and this process goes on until and unless we reach at the last cell. If we are able to reach at the last cell, we have to return the cost, and if we are not able to reach, after this loop we can simply return -1. Let me submit this. I hope it works. Yes, it works, and I hope you get the problem how we can solve it. Thank you.